This session I will be continuing with what we had stopped in the morning. We had come to the end of embedded system design process. So I'll be sharing the screen now. So the 5 steps involved in the design process has been completed in the morning. The 5 steps include the requirements gathering phase, then specification, architectural design, component design, and system integration. We have gone through all these phases in detail, and now we are going to the next section, that is structural and behavioral description of embedded systems. How will you define the structure and how will you define the behavior of an embedded system? So, before going on to describe the structure and behavior of an embedded system, we have to find out a means to describe the structure. What are the notations that can be used to describe the structure? What are the notations used to describe the behavior of a system? So, to describe the structure of a system as well as the behavior, these are the two viewpoints from which we can view a system. A system can be viewed from different angles, like as we can see when we consider the plan a house. When we draw the plan for a house, it has different views, like it has the top view, front view. Uh, Top view we call it as the plan, the front view, etc. So, just like we look at a single figure from different points of view, or a single image from different points of view, the software or the embedded system that is going to be developed has also different viewpoints. So one view is the structural view, another is the behavioral view. Then the structural description, it gives the basic components that make up a system. So a system can have its structural description as well as its behavioral description. Both are necessary for the functioning of a system. Both are necessary for understanding the design of a system, because it is the design that is being translated directly into the passed directly to the implementation phase. So looking at the structure and the behavior of the system, the implementers should be able to implement these details in an effective manner. So there is the structural description as well as the behavioral description. Both go hand in hand for a product to function properly. So structural description means the basic components that make up the system. The principal components, when we consider the GPS systems which we have discussed earlier, the primary components of the system can be viewed from its hardware units, uh, like the display, the frame buffer, memory, CPU, GPS receiver, PAN and IO, etc. These are the primary components, and also there is the software components involved. Hardware components as well as software components together form the components of an embedded system. So in software, we have different software modules like database, renderer, then the user interface, timer, etc. So these are the different components that make up the structure of the system. So to describe the structure or the behavior by behavioral description, what we mean is how the system responds to uh, inputs from the end user. So that's the behavioral description. So how the system behaves in the real world, or what is the behavior of the system that has been designed by the developers, so that it gives the correct functionality. So the functionality of the system can be explained in terms of behavior of the system. So, to describe the structure as well as the behavior of a system, you need certain notations which are universally accepted by all developers. we cannot follow independent descriptions if because if I describe the system in one way, the others who are involved in the project for the development of the system will not understand the notations used by me. So there should be a standard way for describing systems which has been accepted by all, which is known to all, and everybody should follow this notation so that the descriptions can be easily understood and easily translated into a final product. So, to describe the structure as well as the behavior, we make use of a modeling language called the UML. UML stands for Unified Modeling Language. So it is a modeling language, and it's not a programming language. It is a modeling language. Now, what do you mean by a modeling language? So, show you what this UML. Let me take the notes of UML. So UML is Unified Modeling Language. So UML is a language for modeling the system, and this Unified Modeling Language, it can model the structure as well as the behavior of the system. Or in other words, we can say that UML can model the structure, behavior, and architecture of the system. So based on this, the modeling can be divided into structural modeling, behavioral modeling, and architectural modeling. There are three types of modeling involved in development of a software-intensive system. But in the case of an embedded system, we go for structural modeling as well as behavioral modeling, which gives an overall view of the system. But for a software-intensive system, you need structural modeling, behavioral modeling, as well as architectural modeling. So, since we are concerned with embedded systems, we go for structural modeling and behavioral modeling. Now, what is modeling, or what is a modeling language? Models are nothing but a simplification of reality. We want to construct a house, but before constructing a house, we construct a model of the house in the form of a plan. Before the plan for the house, so this plan will help you to visualize the house as it is or as we want it to be. So also now 3D models are available. These are not real things, but they are just simplification of what is going to be built. So uh, the plan that you have, it is in a simple piece of paper. It is a small version of the big house that you are going to build. So it is a simplification of of reality, or simplification of what is going to be built. So likewise, software, before going to build an embedded product, we have to generate a model of the product, and to represent the model of the product, there should be standard notations, and these standard notations should be followed by everyone. And to follow the standard notation, we use a modeling language, and that is called the Unified Modeling Language. And this Unified Modeling Language, it helps to visualize, it helps us to specify the system characteristics, it helps to construct the system, and also it documents various design decisions that has been taken. So you in general, we say that UML is a modeling language for visualizing, specifying, constructing, and documenting the artifacts of a software system, or of a product to be built. And it is a graphical language. UML is a graphical language, which means we represent each and everything in the form of figures or diagrams, or just like when we draw flow charts, we have a start symbol, then we have a decision box, we have arrows connecting these different geometrical shapes, and each of these geometrical shapes in the flowchart has a specific meaning. Likewise, in UML also, there are certain predefined symbols, and each of these symbols have its own meaning. Now, before going on to that, and before we study the structure and behavior of an embedded system, we have to study what are the notations used in UML, because these are the notations which are used to specify the structure and behavior of an embedded system. So we are we have to understand the components or the notations used in UML. We have to understand what are the basic building blocks of UML. So UML, we are going to model an embedded system, and model is nothing but a simplification of what is going to be built. It is not the real product, but you're going to. It can be a picture on a paper showing the different components that make up the system, and or it can be a picture where if it shows the components, then it represents the structure of the system of we call it a structural modeling, and it can also give us the behavior of the system, like if a particular system receives a particular message, what will be the output, what will be the response of the system. So such figures can also be represented, and those figures represent the behavioral model of the system. And in when we come to UML, we have different notations or different diagrams for representing the structure as well as the behavior of the system. So, to study the basic notations in UML, we classify the things, we study the basic structure of UML first. So, there are certain notations used in UML, so we are going to study the classification of UML. In general, we call it as the basic building blocks of UML. This is one of the university questions. So what are the basic building blocks of UML? So the basic building blocks of UML, there are three basic building blocks for UML. There are basically three building blocks. We classify this into things, relationships, and diagrams. So the basic building blocks of UML includes the things, relationships, and diagrams. Now, what are things, what are relationships, and what are diagrams? So the things in UML, they are the nouns of the UML model. Things are the nouns of the UML model. Things in UML, um, whatever noun we come across, we classify it under things. And the things in UML model can be classified into four types: structural things, behavioral things, annotational things, and grouping things. So in UML, the basic building blocks of UML includes things, relationships, and diagrams. And now we are going to study about the things in UML. Things can be classified into four: structural things, behavioral things, annotational things, and grouping things. These are the four kinds of things that we come across in UML, or UML defines notations for these four categories of things, that is structural things, behavioral things, annotational things, and grouping things. Now, what are these structural things? What are behavioral things? What are annotational and grouping things? We have to study all these notations because these are the notations used in the design of embedded systems. So, structural things can be classified into seven categories, and that includes classes, interfaces, collaborations, use cases, active classes, components, and nodes. There are seven structural things in UML. It includes, first of all, classes. The next is interface, third collaboration, use case, active class, components, and node. So we should think when we speak of class, we should first of all what should come to our mind is this: UML is a language for designing object-oriented systems. So it defines all the notations related to an object-oriented system, designs or models for object-oriented systems. So class is one of the structural thing. Then other things include interfaces, collaboration, use case, active classes, components, and now, likewise, the behavioral things include interactions and state machines. Like state machines, it shows the transition from one state to another. Interaction shows interaction between states, and so behavioral things can be classified into two types: interactions and state machines. Then annotational things can be classified. Annotational things in UML, we just use one notation, and that is called the note. And grouping things include package. Usually there is a framework also. Now here we come across the most basic thing, grouping thing in UML is the package. So things in UML can be classified into four types. That is what we have said. That is structural things, behavioral things, annotational things, and grouping things. Out of which Again, these four categories of things can be classified, and the classification is the structural things can be classified into 7 types: classes, interfaces, collaborations, use case, active class, components, and nodes. The behavioral things are 2 types, which includes interactions and state machines. Annotational things include the node, and grouping things include the package. So UML is a modeling language for object-oriented systems developed by OMG, the Object Management Group, had introduced a standard modeling language which can be followed by anyone who is going to design an embedded system. So the advantage is that all the notations will be the same, and to represent a class, UML defines a particular notation, and this notation is used by all of them uniformly. And so, whenever we find the notation of the class, everybody understands that this is a class. The next is relationships. Relationships, basically they can be classified into 4 types: dependency, association, generalization, and realization. We come across it in detail later. Now then, the third building block of UML is the diagrams, and diagrams can be classified into 9 types. There are 9 classes of diagrams, and that includes the class diagram, object diagram, use case diagram. Then we have the sequence diagram, collaboration diagram, activity diagram, state chart diagram, then component and deployment diagram. So these 9 diagrams, which I've told now, they can be basically classified into 2 types: structural diagrams and behavioral diagrams. So diagrams in UML can be classified into 2 types: structural diagrams and behavioral diagrams. And structural diagrams include the class diagram, object diagram, component diagram, and deployment diagram. They are the structural diagrams. Then behavioral diagrams include the rest, that is use case diagram, sequence, collaboration diagram, activity, and state chart diagram. So that is one particular classification of diagrams. That is, diagrams in UML can be classified into 2, as structural diagrams and behavioral diagrams. Structural diagrams, there are 4 structural diagrams and 5 behavioral diagrams. The 4 structural diagrams include class diagram, object diagram, component diagram, and deployment diagram, whereas the 5 behavioral diagrams include sequence diagram, collaboration diagram, activity diagram, state chart diagram, and use case diagram. So this is one classification of diagrams. Again, the same diagrams can be classified into 3, as structural diagram, behavioral diagram, and architectural diagram. So structural diagrams include class and object diagram. Behavioral diagrams is the same as we have said earlier: use case, sequence, collaboration, activity, and state chart diagram are the behavioral diagrams, and the architectural diagrams include the component diagram and deployment diagram. So when we come across this behavioral diagrams, the 5 behavioral diagrams, the 2 diagrams, the sequence diagram and collaboration diagram, which come under behavioral diagrams, they together we call them as interaction diagrams. Sequence and collaboration diagrams together, they are called interaction diagrams. So this is the basic classification of the building blocks of UML. We come across the notation. We have to study the notations used in each of these. Now first we come to the things. In things we have the first category, the structural things. In structural things we have 7 types of structural things. We will look at each one of them in detail. So things in UML, first is the structural things. Now the structural things, we call it as the nouns of the UML model. Whichever noun, when we come across a noun, say a student is a noun, then we classify that student as a structural thing. They are the static parts of the model. That is, once we are going to design a student information system, always the student class will be there. It is not going to change. So they form the static parts of the system, then they represent elements that are either conceptual or physical. So student is something that can exist physically, but there can be other things which are in concept, like a transaction, which we cannot see or touch. It is a concept or a logical entity, can also represent a structural thing. Then These are the characteristics of structural things. Now, structural things include first one is class. Class is a class is a group of objects having identical properties, common behavior, and shared relationship. Graphically, it is represented as a rectangle that includes its name, attributes, and operations as shown below, like as shown in this figure. You can see that it's a rectangle with three compartments. The first compartment represents the name of the class, second compartment represents the attributes, and the third compartment represents operations or methods of the class. So there is the general format which is drawn first, and the example is shown by the side. The name of the class is student, the attributes are register number, name, and department, and the operation involved is add. An add operation is given. You can add a student to this class. Then, so this is about class and its notation. So classes are represented by rectangles with three compartments. In advanced class version of UML, there can be four compartments. The last compartment represents the responsibilities, but here in general, we are only studying about the general notation. So each a class is a rectangle with three compartments. First compartment, you write the name of the class. Second, the attributes of the class, and third, you write the operations of the class. Then the second thing in UML is interface. What is an interface? It is a collection of operations that specifies the service of a class or a component. Graphically, it is represented as a circle with its name near it, and it is often attached to the entity that describes it. So it never stands alone. It is often attached to a thing that which it describes. So here a class is shown there, and this class, it includes all the operations that is related to spell checking. So that is what is shown by the interface there. There is a circle attached to this with a line to the class, and the name of the interface is written as I. Capital I shows that it is an interface, and then followed by the name of the interface. So the name given here is spelling. So this interface is concerned with all the spell checking operations, and most of these spell checking operations occur in the class to which it is attached, and that is interface. Then the third one is collaboration. Collaboration is a collection of elements it is a collection of elements. It can be several objects, and they work together to provide some cooperative behavior which is bigger than the sum of the elements. Some individually the functionalities may be less, but when working together they can have additional functionalities that could be performed. And graphically it is represented as an ellipse with a dashed line. So it is an ellipse, but it's shown with a drawn with a dashed line. Then you have use case. Use case is a sequence of actions that the system performs, and it will give an observable result of value to the end user, to the particular end user. Suppose I'm searching for a book in the library automation system. I have entered the accession number, and the system searches for all possible details regarding the book, like the author, the edition, etc. Everything is going on inside. There is an end-to-end activity going on inside the system, and finally it will return the result to me. And so this particular search operation is a use case, and so, but even though I'm giving just a single input, it is going on to within the system. It is performing a set of operations, and then it yields a result to the actor, the end user. Graphically, it is shown as an ellipse with the name of the use case written inside it. So, we have discussed some things. We have discussed about classes, interfaces, collaboration, use case. Then next we have active class. Active class, it's just like a class, but its behavior is concurrent with other elements. That is, suppose some value of another element changes, then the value of the attributes defined in this class also changes. So its behavior is concurrent with some other elements. So they call this such a class which keeps on changing with some other elements. When some other element change in the system, it's called an active class. And graphically, it is just like a class but with solid borders. Graphically, it represents graphically it is just like a class but with solid borders as shown like this. Now, the same as the class is represented as a rectangle with three compartments. Here, the active class is also a rectangle with three compartments, but the that this is a solid the solid lines are used to show active classes. Then component is the physical and replaceable part of a system which represents packaging of classes and interfaces, and it is graphically represented in this figure. It is a rectangle with two small rectangles by the side, and you write the name of the component inside it. Suppose you have created a file named orderform.java. It is you can delete the file and replace it with a new file. So that is what the definition says, that it is a physical and replaceable part of a system, and represents packaging of several classes, and so this order form can interact with many different classes and interfaces. So to represent such an order form or a replaceable part of a system, you use the components notation. And last thing is the node is the computational It is a computational resource that exists at runtime. Node is a computational resource. Now, for example, a computer system is a resource. It exists now. Most of the processes run in the system, and it has memory, and it has processing capability. And if a particular component, if a particular thing has act as a computational resource and it exists at runtime and with some computational capability and having some memory, then we call it as a node. So a typical example is the computer system, and graphically it is represented as a cube. As shown below, it is represented as a cube with the name of the node written inside it. And this cube can have several components residing inside it. So these are the 7 components that make up the structural things of UML. So things can be classified into structural things. The next is the behavioral things. Now behavioral things, they are the verbs of the UML model. Verbs are the action. So any action performed by the system is called the behavior of the system. So they are the verbs of the UML model. They are the dynamic parts of the model. Dynamic parts means always given an input, they respond to output, and they perform some operation and respond to output. So this is the dynamic part of the UML model, and it represents behavior over time and space. There are two primary kinds of behavioral things. One is the interactions, and other is the state machines. Now, what is an interaction? Interaction is the set of objects exchanging messages, one object communicating with another object for a particular purpose. And this graphically, it is represented by arrows aligned with an arrowhead along with the name of the operation. So display operation, there is a message sent from one unit to another to display a value. Then we represent it in UML with a dash line with an arrow with the name of the interaction written near it. Then the next behavioral thing is the state machines. It is a behavior that specifies the sequence of states an object goes through during its lifetime, and this happens in response to certain events. Now, graphically, a state is represented as rounded rectangles with the name of the state written inside it. So behavioral things are of two types: interactions and state machines. Then you have the annotational things. Annotational things are the explanatory parts of the UML model, and they are the comments. If we want to write a comment or a note, we make use of these annotational things, and the name of the annotational things that UML uses is called the note. And graphically, a note is represented as a rectangle with a dog-eared corner. A corner, this is folded back, folded inside, towards the inside. So it forms a dog-eared corner, and this notation is used to represent the notes in UML. Inside the note, you can write comments like in this you have written this is a web page. So likewise, if you want to give the URL of any particular site, etc., anything, want to note the note symbol of the UML model. So we have structural things, behavioral things, annotational things, and the last is the grouping things. Now, grouping things are the organizational part of the UML model. Organizational part means to separate the components of a system into groups we represent. We use UML notation with the grouping thing, and the primary kind of the grouping thing is called the package in UML. And package is a general purpose mechanism for organizing elements into groups. Structural things, behavioral and other grouping things, they may be placed inside a package, and they are purely conception, and they are purely conception, and that is they exist during development time, uh, only during development time, and just for the purpose of making a system structural, we use package notation. So like for example, all the networking classes in Java, they come under network.lang. So all these packages which are similar in function can be grouped together into a single class. So these are the components that exist conceptually, and they exist during development phase only for writing the program. Graphically, package is represented as a tabbed folder along with the name of it. Like a tabbed folder is a rectangle with a small rectangle above it in one corner, and inside that we can write the name of the package. So these are the structural things in UML. These are the things in UML. So we have classified things as structural things, behavioral things, annotational, and grouping things. So this is the first building block things in UML. We have come across all the things in UML and its various notations. Likewise, we have two more building blocks, that is of UML, that is relationships and diagrams. So relationships in UML, there are four kinds of relationships in UML, that is dependency, association, generalization, and realization. These are the four basic relationships that we come across in UML. So we'll start with these relationships in the next class. And then one more after relationships, there's the second building block relationship, and then we have diagrams in UML. So these four relationships and 9 diagrams, and the various representation, the notation used for representing these relationships and diagrams has to be studied, so that this can be the UML notations are the notations which is used in the entire textbook for designing embedded systems. So we'll continue in the next class with relationships in UML. Thank you.